Hello everyone. In this video I will be explaining about infinite limits and vertical asymptote. Infinite limit is a limit in which the function is increasing or decreasing without bound as x approaches a fixed number. So that kind of limits are called infinite limit. For example, in this figure, limit as x approaches to 2 of f of x, 3 over x minus 2. When you do direct substitution, it's gonna give you 3 over 0. So that will result in infinity, right? What kind of infinity? When you check the limit graphically, when you approach 2 from the right, your graph is heading upward towards positive infinity. So 2 from the right will give you positive infinity. Similarly, limit as x approaches to 2 from the left of 3 over x minus 2 is also infinity. But what kind of infinity? When you approach 2 from the left, your function is heading towards negative infinity. So whenever you have an infinity situation and unbounded limit situation, so these kind of limits are called infinite limits. Your graphs are either heading towards positive infinity or negative infinity, or one part is heading towards positive infinity, the other part is heading towards negative infinity. So those limits are infinite limits. So what about this number that the x value is approaching? So when we approach 2 here, the function is approaching to a fixed, to a vertical line, an invisible vertical line. So that vertical line is called vertical asymptote. All right. So it's a number that the x is approaching when your function is heading towards infinity. So our vertical asymptote here in this graph is x equals 2. Okay, it's an invisible line that function is approaching as x is approaching 2. Okay, so how are we going to find the vertical asymptotes in the questions? We will have vertical asymptote for rational functions only. So rational functions will have vertical asymptote only if the number makes denominator 0, not the numerator. So numbers that make only denominator 0, not the numerator, will give you the vertical asymptote. Okay, let's take a look at some questions. So find vertical asymptote of 2 over 3x minus 2. So there are two ways of solving vertical asymptote questions. First way of solving the question is using a simple way, the way that you already studied in grade 10. It's like equalizing denominator to 0 and finding the number that makes denominator 0. If that number doesn't make the numerator 0, it is your vertical asymptote. Okay, it's pretty simple. Second way is using limits. So limit as x approaches 2. What makes denominator 0? Which is 2 over 3 of 2 over 3x minus 2. When you insert 2 over 3, you are going to get 2 over 0. So whenever you have number other than 0 divided by 0 condition, then there is vertical asymptote. Okay, I have number divided by 0, then the number that x is approaching will be our vertical asymptote. Okay, you either use the limit way, you take the limit as x approaches to the number that makes denominator 0 of f of x. If the result is number over 0, then it is your vertical asymptote. That number that x is approaching is vertical asymptote. If it makes 0 over 0, you do simplification, and in the last step, it is still not number over 0, it's not your vertical asymptote. So as a result, you should have number other than 0 divided by 0 condition at the end to have a vertical asymptote. Alright, in the first way, you just do the simplification at first, then equalize the denominator to 0 to find vertical asymptote. Let's take a look at another check it out question. So I'm going to use the first way first. First way, let's do simplification first. Rewrite f of x first. So x plus 3 at the top, at the bottom, x squared minus 3, that can be rewritten as x minus 3 times x plus 3. X plus 3's will cancel each other, so I will be left with 1 over x minus 3. My function is written in simplest form now, so now I equalize the bottom to 0. So what makes bottom 0 will be my vertical asymptote. Okay, this is basic way, the way that you studied in grade 10. Alright, another way, using limit way. Second way, limit. So limit of what? So you are going to take limit of what makes denominator 0. Without simplifying, look at the original function. What makes denominator 0? X squared minus 9 is 0. Then x squared is 9. Then x is plus and minus 3. So we are going to check limit as x approaches to 3 and limit as x approaches to minus 3, one by one. For 3, what do you get as a result? As a result, when you insert 3 back, 6 over 9, number over 0 condition. So x equals 3 is vertical asymptote, that's for sure. Another number, negative 3, x plus 3 over x squared minus 9. So when you substitute negative 3 back, it's gonna give you 0 over 0. So we should do some simplification then. We don't decide when we see 0 over 0, we rewrite the function. When you rewrite the function, x plus 3, x plus 3, x minus 3, do the simplification, then x plus 3's will cancel each other. So you'll have 1 over x minus 3. Insert negative 3 back, it's gonna be 1 over negative 3, negative 3, negative 6. So it's not number over 0 case, so it's not your vertical asymptote. So x equals negative 3 is not our vertical asymptote because it didn't give us number over 0 case, right? It gives us another number. Limit exists. In order for us to have vertical asymptote, limit should be does not exist, undefined. Alright, so let me summarize. The first way, like we did in grade 10, we do simplification at first, rewrite the function first. So whatever remains at the bottom, equalize it to 0, so that number will give you the vertical asymptote. Second way, the calculus way, you find limit of what makes denominator 0. What makes the original function's denominator to 0? So original function's denominator is 0 when x is plus and minus 3. So we will check limit of both. Limit as x approaches to 3 gives us number over 0, which means limit does not exist, which means it is actually our vertical asymptote. That number that x is approaching is our vertical asymptote. On the other hand, when I use negative 3, then I got 0 over 0 after rewriting and stuff. My limit is 1 over negative 6. Limit exists. If limit exists, there is no vertical asymptote for that number. So that number doesn't give us a vertical asymptote. Alright? So I find the first way easier. I'll do the first way. Okay, for the following questions. Let's move on. Find vertical asymptote of this function. This is an exercise question. So what makes denominator 0 is an simplification at first. Can x squared plus 1 be factored? No, it's not factorable. I cannot factorize this. So let's equalize denominator to 0 right away then. So then x squared is minus 1, which is impossible. So there is no x value that makes denominator 0. So no vertical asymptote. Alright? No number makes denominator 0, so no vertical asymptote. Okay. Okay, these are the polynomial divided by polynomial situations. What if you have trigonometric functions, like in study guides and ministry question? It's asking about vertical asymptote, and in denominator we have a polynomial function, trigonometric function. So the idea is the same. So what makes denominator only 0 will give us the vertical asymptote. So can I do any simplification? No, I can't. I directly equalize sine pi x to 0. Remember the rule. Whenever sine is 0, then the angle, which is pi x, is supposed to be equal to n pi, when n is an integer, right? So get rid of pi, divide both sides by pi, then x is equal to n, where n is an integer. So I don't have any x in the numerator to substitute and back to check whether it makes numerator 0 or not. So this is our answer. Okay, these are our vertical asymptotes. Okay, the integer numbers like negative 1, 0, 1, 2, 3, 4, 5, they're all our vertical asymptotes. Alright, let's continue with another trigonometric function. An exercise question and a ministry question. The same type came 3 times so far in Vasari. So we'll do the same, but there's tangent. We know that tangent can be rewritten as sine over cosine. So our new function becomes sine x divided by x cosine x. Okay, now I can continue solving the question. There is no simplification unlike the polynomials. So we will equalize denominator to 0 and check each number whether that number makes numerator 0 as well. So x times cosine x is equal to 0. So 0 product property. Either x is 0 or cosine x is 0. Can x be 0? We should check it. Since there is no simplification, we should check it by inserting it back, whether it also makes numerator 0. So what is f of 0? Sine 0 over 0 times cosine 0. Sine 0 is 0. Cosine 0 is 1. 1 times 0, 0. 0 over 0 condition, and I can't rewrite the function. I cannot simplify it anymore. So x equals 0 doesn't give me number over 0 condition. So x equals 0 is not my vertical asymptote because the result is not number over 0. Okay, I have 0 over 0. It doesn't give me the vertical asymptote. Result is not number over 0. It's 0 over 0. Okay, so 0 is not my answer. It will appear in the options. The second possibility, cosine x being 0. When cosine is 0, x is, remember the rule, the angle is pi over 2 plus n pi, where n is an integer. So what makes cosine 0 doesn't make sine 0. So it's okay. Then f of this will give you number over 0 case. So x equals pi over 2 plus n pi will be your vertical asymptote. So there are infinitely many vertical asymptotes. Okay, this is the only vertical asymptotes. In the options, you'll have 0 too. Be careful. All right. We didn't have 0 as vertical asymptote because it makes the function 0 over 0. It is supposed to make function number over 0. All right. Okay, let's move on with a ministry exam question, and there's a similar exercise question in the book as well. So the idea is the same in this ministry and exercise question. The question is asking the function that has vertical asymptotes x equals negative 2 and 0 and vanishes at x equals negative 4. So what does vanishes means? So vanishes at x equals negative 4 means it makes x equals negative 4 makes numerator 0. Okay. Vertical asymptote means those numbers make denominator 0. Okay. Vertical asymptote makes denominator only denominator 0, while negative 4 makes numerator 0. So vanishes means this is what makes numerator 0. Vertical asymptote means what makes denominator 0. Alright, so we are going to check each option one by one. So option A. So does negative 4 make numerator 0? Let's see. When you insert negative 4 for x, negative 4 times 2, 8, 8, negative 8 plus 8, 0. So yes, it checks. What about negative 2 and 0? So x equals 2 makes denominator 0 and x equals 0 makes denominator 0. 0 checks, but 2 does not check. It is supposed to be negative 2. Option A is false. Okay, that must be all true. Let's try option B. So what makes numerator 0? Negative 4 times 3, negative 12 plus 12, 0. So it checks. What about denominator? X equals 0 makes denominator 0. 2x plus 4 is 0, so x equals negative 2. So 0 checks, negative 2 checks. So all three of them checks, so B is the answer. Let's continue for the other options to see what we have. So at the top for C, it is 4. 4 makes the numerator 0. It's not negative 4, it's false. In the numerator, 0 makes denominator 0, negative 2 makes denominator 0. Those two checks, but the top did not, so it's not the answer. At the top, we have 0, which is not true. It's supposed to be negative 4, false. At the bottom, negative 2 and negative 4. Negative 2 is true, but negative 4 is not, so it's not our answer either. So in option B only, all three of them check. Okay, the function in option B makes negative 4 makes the numerator 0 in option B, and negative 2 and 0 make denominator 0. So that's the only answer.